Okay, here we go with the Chapter 7 practice test. So be sure you take lots of notes, and remember you get to build an index card of notes for the actual test itself. So the things you look at today that you are a little unsure on would be good things to include in your notes, because you'll have them on the test, number one. And number two, just writing them down and putting them on your index card will help you remember them better. So here we go. Question number one. The correct answer is C. What I would suggest is you create these rainbows. You think of the 4 times the 15 minus the 4 times the 7. So we have the 15 times the 4 minus the 7 times the 4. Now you might say, wait a minute. When you said it, you said the 4 times the 15. You said the 4. Let me get a color here that isn't white. You said the 4 times the 15 minus the 4 times the 7, but they wrote the 15 times the 4 minus the 7 times the 4. Remember, multiplication is commutative, so it doesn't matter whether we do the 15 times the 4 or the 4 times the 15. Either way, we're getting 60. Okay, on to number 2. And remember, any point along the way here, you can pause the video, stop it so you can make some notes, go back and listen to my wonderful voice again, explain something if it didn't make sense the first time. That is the power of doing video on this. Okay, number 2. Which of the following can be written as 10 times x minus, and then it's 10 times x minus y? Well, here we go. 10 times x minus 10 times y. So your answer is letter D. 1 and 2 are the same kind of problems. In problem 1, everything is numbers, and in problem 2, you start getting into variables. Problem number 3. On a school trip to the Space Museum, 30 students visited the astronaut exhibit. The tickets for admission were $18. Which expression can be used to mentally compute? This is whenever you see mentally compute, you know that somebody's doing some kind of a breakdown. And here's how they mentally computed. A is the answer. 30 times 10 plus 30 times 8. So instead of thinking 30 times 18 and going, well, let's see, 8 times 30 is 240, if you do it like they did it in A, you can say, well, 30 times 10 would be 300, and 30 times 8, 8 times 3 is 24, so 8 times 30 is 240, and you'd be able to say, oh, that's $540. So that's the idea of mentally breaking something down. Number 4, identify the like terms in the expression 7x plus 4y plus 3y plus 7. And you'll notice what I did in this case was I decided to underline my terms, and I have the advantage of different colors here. If you didn't have the advantage of different colors, let me get rid of all 3 of these. You can go back and look at it in a minute if you want to. But let's say you're just doing pencil. So if you were just doing pencil on this, you could say, well, I'll underline this one. That's an X. Here's a Y. That's something different. I'll kind of squiggly underline. Oh, there's another Y. I'll kind of squiggly underline. Here's a constant. Maybe I'll put an X under those, X on everything that's a constant. And then you could look and see, well, I squiggly underlined the 4y and the 3y because they're like terms. So that's letter B as your answer. Number 5. The area of a triangle can be determined by 1/2 base times height, or 1/2 BH, where B is the length of the base and H is the length of the height. What's the coefficient? Well, the coefficient is the 1/2. It tells us how many groups of base times height we have. That's what coefficients do. They tell you how many of the variables. Number 6. Which of the following correctly combines the like terms? Well, once again, what I opted to do was I opted to underline things. So I underlined all of my X's in orange and all of my Y's in green. So then I looked at A, and I had 4x plus 7. I didn't underline my constants with anything, because if you need 3 things, you can underline in 2 different colors or underline and squiggle and then leave 1 blank. So I had 4 x's and 2 more x's. Well, there's 6 x's. That's great. But I had 7 constants, and there are no constants in this. This 7, there's nothing to combine or cancel that 7. It would have to appear in the answer. So that got rid of that one. I liked B. 2 x's and 2 more x's were 4 x's. 7 y's, take away 4 y's were 3 y's. That one worked. However, I went through the others just to make sure I hadn't made a mistake with B, because if I got down to C and D, and one of those answers also worked or seemed to work, it would cause me to go back and check that against B. 2 x's and 2 more x's, 4 x's, great. 7 y's minus 4. Oh yeah, no, see this 3y? Somebody made the mistake of taking the 4 away from the 7y. You can't do that. They're different kinds of terms. And then letter D, 4 x's plus 2 more x's, 6 x's, 7 y's plus 4 y's. Yeah, that should have been 11 y's. So, yep, I like my answer B. I'm going to stick with that. I'm going to get a chance to put a star on that when I correct it later. Number 7. Mateo and Haley both collect coins. Mateo has 8 more coins in her collection than Haley. Which expression represents the total coins in both collections? Now, on this one, I ended up, I guess I have to get rid of my little shade here to show you what I did. Because on this one, I went down to the bottom here as a place to show my work, because I needed some space. So Haley, I'm just going to say Haley has C coins. I could pick X, I could pick H for Haley, but C for coins. Haley has C coins. Mateo has 8 more coins in her collection than Haley. So Mateo has, whatever Haley has, Mateo has that plus 8. So I've got, here's Haley. Right here would be Haley. And all of this would be Mateo. So Haley plus Mateo would be 2C plus 8. And there's my expression A. Okay, Bradley rented a fishing boat for a day. Total cost is represented by the expression 3.25 M plus 15. What is the constant in this expression? The constant is the 15. Remember, constants are values that you do not have to have anybody give you any more information to know what they are. So in a case like this 3.25 M plus 15 is probably, the $15 is a fill-up charge. It's not the cost of the gas itself. It's a boat dock. Somebody has to come up and put the hose in the boat, put the nozzle into the gas tank of the boat, and then stand there while the fill-up takes place. They charge you $15 for that person to do that. They're going to charge you $15 whether you buy 1 gallon or 10 gallons or 20 gallons of gas. That's a fixed amount. So if Bradley goes up to the counter before he starts and he says, hey, how much does it cost for gas? They can tell him, well, the 3.25, that's per gallon. How many 3.25s you pay will be based on how many gallons you buy. But there's also a $15 service charge, and we charge that no matter what. That's what makes it a constant. If you break down the other two here, the 3.25 is the coefficient, and the M is the variable. Number 9, what's the GCF, or greatest common factor, of 100 XYZ and 25 XZ? Remember, greatest common factor is the biggest value that goes into both. So, for example, if you were doing 8 and 12, the greatest common factor is 4. 4 is the biggest number that goes into 8 and also goes into 12. One of the things you always want to do when looking at GCFs is you want to ask yourself, does the small value go into the large value? And that's what I did here with my work. I looked at the 25XZ and I said, you know what, 25XZ goes into 100XYZ. Let me break down the work I did on that. What's a good color to pick here? Let's be blue right now. So here's what I did on that. I took my 100 x, y, z, and I put it over 25 x, z. Okay, and notice I spread things out there. And then I asked myself this. Could I factor, I don't want to draw a square because I don't want it to look like a giant 1. Could I factor that? Well, absolutely. 100 divided by 25 is 4 over 1. So that goes in evenly. I should probably pick a darker color for that so you'll be able to see it. There you go. And then I did the same thing right here. Well, this one actually, whoops, sorry about that. This one actually does make a 1. I'll go back to my orange. That's been my standard 1 color. That actually does make a 1, x divided by x. This also makes a 1, z divided by z. So if I was to actually factor this, I'd say 25 goes into 100 4 times right there. The x's cancel to 1, the z's cancel to 1, I end up with a y. It doesn't really matter what this is right here. That's not the point. The point is it went in. The small one went into the large one. It also goes into itself. Everything goes into itself one time. So therefore, the 25xz is the largest value that can go into both. Always, always, and always check to see does the small one go into the large one evenly. Because if it does, it will be your greatest common factor. All right, on to the next page. Problem number 10. So a triangle has side lengths of 4x minus 10, 2x plus 6, and 5x. What expression represents the perimeter of the triangle? Remember, perimeter means all the way around. So the first thing I did, and I did it in my head, didn't show it here, but I should show it here. First thing I did was I changed this from 4x minus 10 to 4x plus negative 10. And then I wrote down my 3 items, my 3 sides, 4x plus negative 10, 2x plus 6, 5x, and I added them together. And remember, on the adding together part, you can almost think of a line being drawn right there. These are the x's. They can only add to other x's. You can't put those with anything of the constants. These are the ones. They can only add with other ones. You can't put those together with the x's. So 4x, 2x makes 6, plus 5 more x makes 11 x's. Negative 10 plus positive 6 makes negative 4. We get answer C. Number 11. The expression 2x plus 8 represents the number of miles that Trent jogged during a race. 5x represents the number of miles that Ling jogged during the same race in x hours. So they're telling you what the x stands for. The x stands for number of hours. That doesn't really matter what the x stands for because you're just looking for a difference. How many more? Anytime you see how many more, you are looking at a difference problem. So the negative 8 we're not going to use here because Ling's amount is shown only with x's. So we're just getting the difference of the amounts, the terms that have the variables. So we're doing 5x, and we're taking away 2.2x. Now, a place that might get confusing for some students is, why is this a minus 8 instead of a plus 8? Well, remember, we're taking away this whole thing. Let me just grab a highlighter here. We're taking away all of, whoa, that's not the color I wanted. There we are. We're taking away that whole thing. So it's 5x, take away the 2.2x right here. And it's 5x, take away the 8. You could change this if you wanted to. You could change this to plus a negative 1. So for some students, this would help. Change that to plus and then put a negative 1 here. And if you're saying, well, where did the negative 1 come from? Let me go back a step. Go back 2 steps, 3 steps. There we go. So I could have put a 1 here to start with, right? 1 times 2x plus 8 equals 2x plus 8. That doesn't change anything. What it does help with for some students is if I then say, well, I'm going to change this to adding the opposite, now we can see that we've got negative 1 times 2x, negative 2x, and we have negative 1 times 8, which ends up being our negative 8. So our answer ends up being 2.8x minus the 8. Onward we go to number 12. So in 12, what we're looking at is we're looking at this expression. 13 times negative 16 plus 14 times positive 16. And it would be rewritten as the 16, which is common, times the 13, the negative 13, excuse me, plus the 14. So the biggest question is, where does the negative 13 come from? So here's what happens with this problem. If you think of the 13 times the negative 16, we want to take 16 out. 16 is the common factor. Well, when we divide this negative 16 by 16, when we take that out, we get a negative 1. Right? Negative 16 divided by 16 is a negative 1. So we end up with this. After the 16 comes out, we end up with 13 times negative 1 plus 14 times positive 1, and all of that times the 16. Which means that when you multiply the 13 times the negative 1, you get negative 13 right there. 14 times the positive 1, you get positive 14. And then all of that multiplied by the 16. It's a challenging concept. If you think through it, I think it'll make sense. If it doesn't, you're welcome to ask me some questions about it. Let's move on to problem number 13. So on problem 13, we're told that the width of a rectangle is 4x and its length is 6x minus 2. So here's my rectangle. 4x times 6x minus 2 gives me a total of 24x squared minus 8. 4x times 6x, 24x squared. 4x times 2, negative 8x. What happens if the area, or what happens to the area if the length is doubled? So if that 6x minus 2 gets doubled, what happens? Well, what happens is the area doubles. And here is the illustration of why that happens. Get rid of my rectangle there. So if we double it, we end up with another section that's 6x minus 2 long. So now we have a 4x times a 6x minus 2 and another 4x times a 6x minus 2. We would end up doubling the area. If we doubled both the length and the width, let me just show you really quick here. Let me grab a blank. If we had something like this, if you had a rectangle, and I'll switch away from x's, I'll switch to just numbers. Let's say this was 3 and that was 2. We know the area of that is 6 square units. If these were in feet, that's now 6 square feet. Well, if you double the length, you put another 3 on here, now you get another 6 square feet. So now you've got 12. You doubled it. If you doubled the width also of all that, if you double the length and the width, you end up making your total area 4 times larger. Notice we've now gone to 24 square feet altogether. Okay, on to 14. Oops, that did not do what I wanted it to do. There we go. Number 14. Write an expression in factored form that is equivalent to 3x, or excuse me, 3/4 x plus 24. So remember, when you're doing factored form, what you're looking for is the biggest number that goes into both. Well, in this case, the biggest value that goes into both 3/4 and 24 is 3/4. 3/4 goes into 3/4 itself one time. We can see that right here. And 3/4 goes into 24 32 times. Remember, goes into means divides into. So if I divide 3/4 into 24, or another way of saying that, if I divide 24 by 3/4, I get 32. And so my factored form would be 3/4 times x plus 32. Again, you'll have some chances to ask questions before the test if there are a couple of these you still want to clear up. Okay, so 15 and 16 go together. An animal hospital provides aid to sick and injured sea turtles. Cost for visiting the hospital for X number of visitors is shown in the table. You might wonder, well, it's a hospital, you have to pay to go in. Sure, you get to go visit the sea turtles while they're recuperating, and they've got to charge something for that because that's how they help fund their sea turtle research. This, I'm not sure why that extra 3 is sitting there. Let's get rid of that. So, greatest common factor for 22.5 and 15 is 7.5. 7.5 is the biggest thing that goes into each. So when it says write an expression in factored form that is equivalent to the sum, which is adding weekday and weekend tickets. So we're taking out 7.5 from both of these. We have to add them. First, 22.5 and 15. Then we have the greatest common factor, which is 7.5. So our factored form would be 7.5 times 3x plus 2. And then 16 says, write an expression to show how much greater the cost is for a weekend ticket than a weekday ticket. Well, to get the difference, you'd have to go ahead and do the 15x minus the 7.5x. That's 7.5. And the 10 minus the 5. That's going to be the 5. Let me stick this answer down here and put my work above it just so you can see what I did on this problem. So what I did was I said, well, you've got the 15x minus the 7.5x. Those were additions. Let me grab a different color here. And you've got the 10 here. This was 15x plus 10. That was plus 5. That's where I got the 5. So 15x take away 7.5x is 7.5. 10 take away 5 is 5. All right. We're rounding the clubhouse turn, which means we're almost done with this race. Number 17. The perimeter of a square-shaped garden is 12x plus 20 feet. Write an expression to represent the length of one side of the garden. Keyword right here, square-shaped garden. Square means all the sides are the same. So we divide the perimeter, 12x plus 20, by 4. Now, when we divide that, you have to divide the 12x by 4 and the 20 by 4. And that gives you 3x plus 5 on each side. And last, number 18. Which expression in factored form is equivalent to 1/5 x plus 10? And the answer is A. Remember, we're looking for the common factor. Well, 1/5 can go into 1/5 one time. That's the 1x. And 10 divided by 1/5 is 50. So we get 1/5 times x plus 50. All right, so you've had a chance to go through and check all this out. What I'd like you to do now is I've created a form. There's a form back on the website. And I would like you to go into that form and list any questions from this you want to discuss further before the test. And what we'll do is we'll have a chance to ask some questions before the test, anything you need to clarify. You should also be working on your index card of notes. You got that index card last week from Emily. If you need a new one, go back and ask Emily. She can give you a replacement. Okay? And then do your studying. Be prepared to kick some test butt tomorrow.